Hello, this is a short podcast on reading databases using SQL or SQL with Python. So companies nowadays have a lot of data which they need to store in a systematic way. Well, this has probably always been true. For a firm, this could be information about customers' orders or the inventory. And for very large data sets, you need something more sophisticated than an Excel file required. And that's just because you could have multiple people updating the file, and you want records to be automatically updated, and some of the information could be used in multiple places. For example, you want to have an inventory of stock, and also the sales team also need access to see what's available. So a lot of data is stored in databases, and this has been true for a long time. There are many types of databases. There are object-oriented databases and hierarchical databases. At the moment, the most common type of database used in the industry is probably called relational databases. And we'll see later, essentially, the different ways to define this, but for our purposes, just the data is in a table, essentially. So structured query language, SQL, is a way to communicate with a database and to get input data into the database and also output data from the data. So SQL is a standard of the American National Standards Institute, standardized 1986. That means there can be many databases, say products like MySQL or products from IBM or Oracle, but because SQL standard, once you learn SQL, you can extract data from all these different databases. Okay, so here we're just going to have a very basic introduction to accessing data from a relational database using this SQL, and it's obviously going to be Python based. Okay, so below is an example of a table for a supermarket. So essentially it's a table. So you have the week. So it's the orders. So you're ordering goods from a farm. So you have the date when the orders were made, number of orders, and then the farm ID. And one of the key things in this kind of database is you don't want to have the same information in two places at one time. So here you could have, in principle, the farm ID points to another table that tells you information like what the name of the farm is, how many acres it has, and the thing is, if you want to, very naively, if you have information spread over different tables and the same information's in different places, then if you want to update that information, it gets very hard because it's spread out everywhere. Whereas if you kind of break up a table into different tables, where you have a farm ID and then the information about the farm. Let's see here, the farm information is used for one order here, and so one of the ideas of these relational databases is the fact that information is sort of split between tables, and there's some kind of theory behind that, and there's some jargon called normalization. So the bottom line for these kind of relational databases is essentially a bunch of tables, and we'll see later on there's ways to extract data from multiple tables and using things like join that allows you to get information from multiple tables. Okay, so most databases are run as computer programs, and then you have some client operators which can connect to the database to query the information. This takes a bit of configuration, and it's probably a bit too sophisticated for our purposes, where we just want to learn some of the basics, basic syntax of SQL. So we're going to use something called SQLlite. So this is a library that implements SQL to store data stored in a database. However, the database is actually just a file. And this just makes it easier. This means you can just download the file, call some Python, and you don't have to kind of configure the database or worry about passwords and accessibility. So this sounds a bit naive, but SQLlite is widely used in mobile phone applications, so it's quite a common format. And as I say, we're using it really because it allows us to gain some experience just with the SQL commands without the hassle of connected to a database server, which is going to be kind of specific to the country. And there's some information here. I'll put the slides up as well as the podcast. So Python has a library called SQLlite 3, and it can read a database in a file using SQL. Okay, so here's an example of extracting using Python to extract information from a table. So the information in the database is stored in something called supermarket.db. So this contains the database. It's a file on disk, and the code below is in the file extract supermarket.py, which I put on the DLE as well. So you have import SQLlite 3. You make a connection to the file, and then you have this cursor idea. And then, so the cursor is connected to the database, and then you can execute an SQL command. So what this command here is select star from orders. Orders is the name of the table. Star just means select essentially everything. And then so it executes this command. The results are stored in cursor as well. And then you can do result equals cursor.fetchAll. And result is now a kind of an array of arrays. We'll see on the next slide what it produces. And then you can loop over the rows of what's in it. Okay, and here's something down at the bottom. So instead of having the loop over things here, so here we extracted everything in the table. And this idea, the next one we do the same SQL command. So we just select star from orders. And then we do print cursor equals fetch1, and in this case we'll just get the first row of the table. So what does the output look like? So here's the that run Python script. So here's the week number, here's the orders, here's the farm ID, and then here's some information of the dates when the order was sent. And if you do this fetch1, you get the first row at the top here. Okay. So the key thing here is when you look on SQL, the actual command is select star from orders. So that's the SQL command, and then all the stuff at the top is Python, and then eventually you get a kind of array of results which you can kind of print off. Okay, so that was a kind of bare bones. So that gives you some way of accessing SQL, but there's actually so that just dumps out all the information. But what you really want to do is make specific queries of SQL. So we're going from the same database, input SQLlite 3. We'll make connection to the database, which is just the file on disk, supermarket.db. And then we have this cursor idea, which is the way we're going to execute commands. And now this time the SQL command is select star from orders, where date equals 2019-4/15. So now we're actually extracting a specific row, and we're actually triggering on the date. So this is different. So now we can actually obviously one of the things with SQL, you want to have all this data and you want to get some kind of insight from it. And then there's a whole bunch of syntax in SQL about how to do kind of matches. So this one is matching on the date. So you execute the command. Here we're just going to put cursor.fetch1, which extracts the result of this SQL command, puts it into res, and then you can print res off. And you see here, so this is the actual column. Sorry, this is the row of the database, and here you can see that it's matched this date here. So 15th of April. If we go back to the previous one, so now we had all these different rows, and now, well, using that where command, we've just selected off this single one, and you know, because we could be interested in the date for that month, and there's obviously different syntax to make you know, more complex queries, date ranges, things like that. And then down at the bottom, the actual structure returned is some kind of a tuple or array type thing. And here I just show you can get res, which gives you the row. And then if you want to look at the individual elements, do this square brackets 1 thing, and you can extract specific numbers for later for analysis. Okay, so so this is just a piece of code of how this example was created. So a database, for these kind of relational databases, there's kind of a schema. And what a schema is just a fancy way of saying that it tells you what the rows, the structure of the rows of the database. And so in our example, so we were looking at this kind of database. I extended a little bit. So you have the week, the date. So you need to tell the database that this is a date. Orders is an integer. Week's an integer. And farm ID is an integer. So that's what a schema does. It tells you what the structure of the database is. And this allows you to check when you input things. You don't input like a string when you're meant to be inputting an integer. So this is part of the script I used to create this. So use the SQLlite, make the connection. So supermarket AB is going to get written. Have this cursor, then SQL command. So here we have create table orders. Orders is the name of the table. So week is an integer. So we're using this as the primary key. So this is the main kind of the main index of the table. That's what the primary key means. Orders is an integer. Farm ID is an integer. And then date, you tell SQL that date is actually a date. And then you execute the command. So that's created a schema. So it's created a table, an empty table called orders, which says up here. And then if you want to fill data into the things, some of the stuff, the scripts will be available online. So you have this idea of the SQL command is insert into orders. So you're inserting some information into orders. You say here's the week, orders, farm ID. This means cut off a bit, and this is date. And then afterwards you have the specific values. So in this case, you're putting in week 30, orders 100, farm ID is 1, and this one's cut off is the date. And this is the way you kind of insert a single row into the table. And so obviously you would kind of build these things up using kind of Python to automate these things. Okay, and so we created the table. This execute. We have this new SQL command. This cursor again executes the SQL command, and this inserts this row into the table. And then finally you have to do the commit, which just kind of saves all the information.